All right, this video is over factoring. And the factoring problems that we're going to go through on this video should be reviewed. So you should have seen these before, but they're going through them in case you need a little bit of a reminder. So we'll go through 4 methods of factoring in this video. I'm going to start with the greatest common factor, which you guys probably have been doing for some time. So just give me a second to connect my iPad here and we'll get started. Okay, so greatest common factor, whenever you factor with greatest common factor, you can do that with any number of terms. And you should always look to see if you can take out a greatest common factor first before trying any of the other methods. And then if you are doing, if you have a problem with 4 terms, you can use grouping. If you have a polynomial with 3 terms, you could factor using the trinomial method. And then difference of squares is one method that you can use when you have just 2 terms. So anyway, let's talk about greatest common factor first. All right, so our first example is 9y to the 5th plus y squared. So we're looking to see what divides into both of those terms, which will be our greatest common factor. And so y squared can go into it. So we'll write that outside of the parentheses. And then we'll divide both terms by y squared. So 9y to the 5th divided by 9y squared is 9y cubed. And then y squared, the second term divided by y squared is 1. It's important that you put the 1 there. You can't just leave that out, okay? It acts as a placeholder. And that's our answer. And so anytime we're factoring, you should be able to multiply your answer together and get what you started with. So you can always check to make sure that you did it right, okay? We know this is completely factored because the polynomial factors are prime. And what that means is this 9y cubed plus 1 is a polynomial factor, but we can't factor that any further. All right, so in the second problem, you may just, after I write it out, I would suggest just pausing the video and trying to work it out on your own real quick. And then just to see if you got the same thing that I did. Okay, so the greatest common factor in this case it would be 2t squared. All right, so 2 divides into 6, 8, and 12. X is not in the last term, so x cannot be part of the greatest common factor. And then all 3 terms have a t, and so we take the one with the lowest exponent, which is t squared. And now we go through and divide everything by 2t squared. So it gives us 3x squared t for the first term in the parentheses, 4xt squared for the second term, and then 6 for the last term. And so that's our answer. Okay. All right, so next we're going to go through grouping, which is a method you can use when you have 4 terms. Okay. Okay, so let's start with 15xy minus 20x plus 6y minus 8. And so usually when I do grouping, I like to split the 2 terms or the problem into 2. And so sometimes people use parentheses to do that. I just usually draw a line. But what we're going to do is take out the greatest common factor from the first 2 terms and then also the greatest common factor from the last 2 terms. So from the first 2 terms, we can take out a 5x, which leaves us with 3y minus 4. And from the second 2 terms, we can take out a 2, a positive 2, which gives us 3y minus 4. And so our answer then is 3y minus 4 times 5x plus 2. Okay. And so with grouping, when you take out that greatest common factor from each place, you're looking to get the same thing in each parentheses. All right. So in this case, we have 3y minus 4 in both of those parentheses. And so a binomial of 3 minus 4 is one of the factors in our answer. And then the other binomial is just the greatest common factors that we took out, which is 5x plus 2. Okay. All right, so let's go through another grouping problem. So again, you might pause the video and give this one a try. This one's a little bit tricky, so see if you can figure it out. Okay, so as I go through it, if I go ahead and split it up with the first two terms and the last two terms, what you'll find out pretty quickly is there's no greatest common factor from the first two terms, and there's also not a greatest common factor in the last two terms. So in this situation, which comes up every now and again, you just need to rearrange the terms and then see if you can do it another way. So a lot of times those two middle terms can be switched. So I'm going to rewrite this problem as mp squared plus 7m plus 21 plus 3p squared. And so now I split it up and I can take out a 7 from the first two terms. I'm sorry, no, I can take out an m from the first two terms, which gives us p squared plus 7. And then we can take out a positive 3 from the second two terms, which is 7 plus p squared. Okay. And of course, p squared plus 7 and 7 plus p squared are the same thing since it's addition. So our answer is going to be p squared plus 7 is one factor, and then m plus 3 is the second factor. And that's it. Okay. All right, so let's talk about trinomials. And this is one of the probably most common methods of factoring that we have to do. Okay, so we're going to use this method anytime you're factoring a polynomial with 3 terms or a trinomial. Now, I didn't mention this before, but for any problem, you should always look to see if you can do a greatest common factor first. Okay, and so in this case, there's not anything that divides into 6, 17, and 14, and then the 14 doesn't have an x. So I can't take out a greatest common factor. But to do the trinomial method, what we're going to do is we're going to multiply the first term and the last term together, which gives us negative 84. Okay, so again, this comes from taking the 6 and the 14, negative 14, and multiplying those two things together. Okay, that's how we get negative 84. And then the middle term goes kind of in the bottom part of our x, which is a negative 17. And so what we're looking for is what two numbers multiply to negative 84 and add together to negative 17. And so a lot of times this is not always immediately apparent. So if this middle term is negative, or the number at the bottom of the x is negative, then we know that of the two numbers that are going to multiply together, the larger number has to be negative. So we can just start listing out numbers. So for example, like we can try negative 84 and 1. Okay, do those add to negative 17? No. So then you could try negative 42 and 2. Okay. 3 doesn't go into 84. We can take 84 divided by 4 to get negative 21 and 4. Okay, well, those do multiply, or those do add together to give us negative 17. So our two numbers that we're looking for are negative 21 and 4. And so what we're going to do with those negative 21 and 4 is we're going to rewrite the problem, but we're going to replace negative 17 with those two numbers. So we say 6x squared minus 21x plus 4x minus 14. And once you get to this point, then it's just like a grouping problem. Okay, so we go ahead and split it. First two terms, I can take out a 3x, which gives us 2x minus 7. The second two terms, you can take out a 2, which gives you 2x minus 7. And so our answer is 2x minus 7 and 3x plus 2. And once again, you can always double check by just foiling those two things back together, and you're going to get what you started with. All right, so let me give you another one. And again, for number 6, I would suggest that you pause the video and try this on your own. All right, so 3 times negative 75, or excuse me, 3 times negative 25 is negative 75. So we're looking for numbers that multiply to negative 75 and add to negative 10. That's going to be negative 15 and a positive 5. So we have 3x squared minus 15x plus 5x minus 25. And so as we work that through, our final answer is x minus 5 times 3x plus 5. Okay. All right, the last thing we're going to talk about in this video is difference of squares. And so there is a formula for this one, where if you have a squared minus b squared, that factors to be a minus b times a plus b. Okay, so this works when both the first term and the last term are perfect squares. And so what the formula is telling us that we're going to do is we're just going to take the square root of each term, put them in binomials where one's addition and one's subtraction. All right, so number 7, 9x squared minus 25. Well, 9 and 25 are both perfect squares. You take the square root of x squared, which is just x, and a subtraction. That's the key thing. This does not work for addition. So when we factor this, it's going to be 3x minus 5, 3x plus 5. Okay, again, the square root of 9x squared is 3x. The square root of 25 is 5. That's where those numbers are coming from. And with difference of squares, one's minus and one's plus. Okay, let's go and give this one a try. And that'll be our answer for number 8. Okay, the square root of 4x squared is 2x. The square root of 9y squared is 3y, and then one's minus and one's plus, which gives us our answer. All right, so that's it for this first video. And then the second video of this section will go through some harder problems, which some of those might be new for some of you.